Hello friends, so welcome to my channel. Today we are going to see a very interesting statistical tool called Analysis of Variance, and we are going to focus on one-way analysis. I'm Dr. Sujit, and let's see how it goes. Before we start, let's take a problem, and this problem is about a teacher who is teaching three sections of students, and she has just finalized her midterm examination. The result shows that uh, the means are slightly different, and she has a feeling that whether these groups are really different or not. And she came to me asking if there is any technique, statistical tools through which we can statistically prove that these groups are actually different. So this is the problem at hand, and we are going to use analysis of variance to find this. So before I come to analysis of variance, let us see what are the marks awarded in the midterm examination for these three groups. Okay, so this is out of 100, so you can see that there are different marks in these sections. Okay, now one way of understanding a series of observations is through its mean. Let's see what are the means of these three groups. The first group, section A, has mean of 77, second one is having mean of 80, and third one is having mean of 84. Based on this mean, most probably we are not able to understand anything about the variability, because that is just a number, and hence we need to use something else in order to find out its variance, and that is exactly captured here. For example, now you see this is another group of three groups we have, and you can see that the first group is having all five observations as 75, so automatically mean is going to be 75. And group 2 has some variability in these observations, but still the mean is 75. And the third group is having a lot of variations, but still the mean is 75, and hence with the help of only mean, most probably we may not be able to capture the variability. Okay, so can you see that these are all same, right? So in our case also you can see that the three sections that we talked about has got different means. So there must be some variability that we must be capturing, so that we may able to tell whether these groups are actually different in terms of their variability. Okay, so now let's see. ANOVA is basically a technique where you analyze multiple groups of data to determine the variability, and the variability actually comes from two sources. The first one is between the samples. This is what we are trying to check whether groups are different, and then within the samples, because the observations or the numbers or scores that we have may not be exactly same, like in our case, right? So the variability that is captured between the group is called as systematic factor. That is where we are going to focus to check whether the groups are different or not, right? And also the variability within the group is known as random factor, showing the numbers are different within the group. Okay, so we will see this. Okay. And then of course these two variability, if we add, then we get the total variability. So in today's lecture we are going to calculate all these three variability of these samples, and let's see how we calculate this, right? But before I calculate anything, let me just tell you, ANOVA basically believes that there are no real difference exist between these groups, right? And then based on the critical value, it tests whether this null hypothesis is accepted or rejected. So don't worry, we are going to use very simple maths in order to find out these two values to accept or reject our null hypothesis, right? So total variance is actually by taking all the groups together. So we know that we have three groups and there are 10 in each group, right? So typically if I take all the groups together, then the mean comes to as 80, as you can see that, right? So this is the variability we captured by taking all the three groups together, right? So this is something called total variability. Okay, so that total variability can be calculated using a very simple calculation by seeing how much they are deviating from the mean, right? And typically if you take the deviation, most likely you will find some numbers are positive and some numbers are negative. So if you add that variability just like that, then probably positive values may be cancelling negative values, and we do not want to do that, and hence we use sum of squares. So once you take the square, the negative values will automatically will become positive values. We will see this in subsequent slides, but for the time being, please understand that the total variability is combination of two variabilities that is coming from the between groups and from the within groups. Okay, so we will talk about this SSB and SSW, which is basically sum of squares between and sum of squares with it. So now, in order to calculate this variability of total, what we need to do is first we take the mean and take a deviation and then the square it. So this formula basically does the same thing, right? This formula does the same thing. We will calculate using this formula, okay, and where xi is observation and xt is combined mean. Now variance within the group. Typically in our data you can see that everybody has not got the same mark, right? So you see this in group A, the students scored 70, 81, 68 and something like that, and the variation or variability comes because of these different numbers, and this is true for all other groups as well, right? So you can see that as a result the mean is also very different, right? So this is how we can calculate the variance within the group. So this formula is exactly the same. You can take the observation minus the mean and then you square it, and I have already told why we square it, because we don't want negative numbers. We just square it so that negative becomes positive numbers. Okay. So now between is interesting because we are now comparing group A with group B, group B with group C, and this is how we calculate the sum of square between the groups. The formula is again slightly complicated in the sense we compare the mean of this group with the total mean, and then we get the deviation as mentioned in this formula, and then we square it, right? Since we are dealing with mean, so we multiply with n, which is the number of observations, so that we get exactly the variance between the group, right? Let's calculate first the total sum of square. As pointed out, total sum of square is calculated by combining all the three groups and then take the mean, which is 80.44. So now you find out the difference between observation and the mean. So that basically means how much they are deviating from the mean, which is actually captured here, which is x minus x bar. This is x and this one is x bar. So this is 70 minus 80.44, and you get the answer as this. And like that you can see that there are some positive numbers and some negative numbers, right? If this score is more than the average, then you get the positive number. If it is exactly equal, you get 0, and if it is less, you get negative number. Okay, and now once you have these numbers, if you add, probably you will see that many positive numbers will be cancelling out the negative numbers. We don't do that because we want to keep all the variability from the mean, and hence what we do is we take this mean deviation and square it, and if you square it, you can see that all the numbers will become positive, and then we take sum of this as the total sum of square, and that in our case is 1588.86. So this is the total variability in our groups that we have. Now let's go to the other one, which is within the variation within the group. This variation within the group is very simple calculation where exactly same type of calculation, but here you are doing this for only that particular group. For example, we are taking section A. We have got 10 students and these are the marks, and you can see that this is the mean. So this mean is used in order to find the deviation. So it is 70 minus 76.96 is minus 7, and like that we continue like for all the observations, right? Now if you add here, then also you can see that many negative numbers will be cancelling the positive number. That we do not do. So what we do is we basically square it so that every number will become positive, and hence you are going to get the total, which is actually 507.59. The same thing is true with the other group. I have not mentioned the steps, but you can see that this is exactly the same calculation like we did for section A, and hence you get the total, you can see that within the group variation as 566.13, and this is for the third group, right? And what we need to do in order to find this within, we just add all these three variances, and then you add, then you get a number, and that number is the value of SSW, right? So in our case, the SSW is 1348.78. Okay, so this is the variability within the group, because we are taking the mean of the group and then taking the deviation and then squaring it. Okay, so now next step is to get sum of squares between the group. How do we get this information? This is very simple. We are basically finding out the value of SSB from the value of TSS and SSW. You all know that TSS is equal to SSB plus SSW. So we have already got the value of TSS and also the value of SSW we have. Using this information, we can get the value of SSB to be like 240.08. This is one way of doing it, or else you probably can use also the formula to get SSB. The formula is the group. We have three groups, so we have three means. So this 3 means is subtracted with the combined mean, which is we're taking all the groups together, and then you square it multiplied by n. Here the n is number of observations in each group, right? In our case it is 10, so it is multiplied by 10. So once you are clear about SSB and you have the value of SSB, the next important part is to calculate F ratio. F ratio, as the name suggests, that it is a ratio of two things. Broadly speaking, it is the ratio between sum of square, which is or between, divided by sum of square within, right? Taking the sum of square between divided by its degree of freedom of this is popularly known as numerator's degree of freedom, and you take the step 2, finding out the SSW divided by the degree of freedom of the denominator. Now please understand that here we are using degree of freedom. We will explain that degree of freedom in the next slide, but for the time being, for you to understand that, since we are talking about between variations, so how many groups we are having? We are having 3 groups. So 3 minus 1 is the degree of freedom of the numerator, which is equal to 2. And in the second one, we are talking about within, right? When you talk about within, then we have got in each group 10 observations, so total observations are 30, and we have 3 groups, so 30 minus 3, which is giving you this 27. Okay, so once we have these numbers, then you take the ratio of step 1 divided by step 2, right? Typically when you see this step 1 divided by step 2, you have a feeling that step 1, that is the sum of square between these groups, is nothing but F ratio times the sum of square within. And if between is very high and within is a very small value, so in that case you tend to get f ratio as a bigger number. And f ratio as a bigger number basically indicates that there is a possibility of rejecting the null hypothesis and proving that these two or these groups are actually different, right? So this may sound little complicated as of now, but when we calculate, it becomes very clear and it is very easy also, right? And here, once we get a value of f ratio, then with that value, how do we know whether this is accepted or rejected? That basically means whether we need to accept the null hypothesis or reject the null hypothesis. So for that, we need to find out a tabulated f value for the respective degree of freedoms, right? In this case, we have degree of freedom of 2 and 27. So numerator degree of freedom is 2, denominator is 27. So we need to go and check the f table, and then we compare. That will be your critical value to compare with, to accept or reject the null hypothesis. Now, before we get into f table, so here very quick understanding on degree of freedom. So degree of freedom of numerator, we are talking about this. I just explained just now. Since we have got 3 groups, so it is 3 minus 1, which is equal to 2. And for the denominator, the same thing. We have got 3 groups, but it is within. So within we have got 10, 10, 10 observations. That basically adds up to 30. So it's 30 minus 3, which is actually giving you 27. So that is how this 2 and 27 comes into picture. Okay. So one more understanding of degree of freedom is something which is very simple. Now let's say what exactly is degree of freedom? Degree of freedom basically indicates the number of independent values that can vary in an analysis without breaking the constraint. Sounds complicated, right? It's not that complicated. So let's take one example for you to understand what exactly is degree of freedom. So degree of freedom is basically, let's say you have got 4 numbers which adds up to 25. Okay. So now if it is like this, if I ask you to choose numbers, then how many numbers you can choose with freedom? That basically means there is no constraint on that. So in this case, let's say if I ask you to pick 4 numbers which can add up to 25, most likely in that case you can choose first number, you can choose second number, you can choose third number, but the fourth number you cannot choose because it is already fixed. Once you take these 3, then fourth is automatically known, and hence you do not have freedom to choose the fourth number. So how many observations are, how many numbers you can pick? Only 3. So this is how we get the degree of freedom. So in this case, how many numbers you are supposed to pick? It's 4. 4 minus 1, which is the degree of freedom. So that is how you are getting 3 as degree of freedom. But in case of number of observations and groups like we had, like number of for the within degree of freedom calculation of denominator, what we use, number of observations minus number of groups. So we have 3 groups and 30 observations, and that is how we got the value 27 for this. Okay. Now coming to this particular important step of calculating f ratio, right? So f ratio, I have already mentioned that f ratios can be calculated in 2 steps. Step 1 is about the numerator. So in the numerator, what you take is between variations. So SSB, so that we have got as 240.08. we have already calculated this. That is divided by degree of freedom of numerator, which is 3 groups minus 1, which is equal to 2. So the value is 120.04. What about step 2? Step 2 is within, so we got the value within as 1348.78 before. What is the degree of freedom for the denominator? It's like 30 observation minus 3 groups, 27. So divided by 27 and you get the value 49.95 as your the value for this denominator. Now once these steps are calculated, then F ratio is nothing but it is the ratio of step 1 divided by step 2. So that value you are getting as 2.40 for F ratio. That basically means the within so between variation is 2.4 times the random variations or within variations. How do we know whether this 2.4 is good enough for us to come to this conclusion that groups are actually different? For that, we need to get into tabulated value or critical value, you can call it, for the same degree of freedom of numerator and denominator like 2 and 27. Today I'm going to tell you how to get your own F table in Excel. So formula is very simple. So this is how I got my F table, and here you can see this is the formula. Just write equal F dot INV dot RT. RT is the right tail and the probability. This is very important. You need to explain Excel what is the probability. So here probability I have taken is like 0.01. So that basically means 99% level of significance or something like that. And then you have the degree of freedom 1, which is the numerator first and the denominator first. And then you put this in the bracket and you enter it, then automatically this can be done. Right? Anyway, so how do you find the value, critical value? So you take the degree of freedom as 2 from the numerator side, and from the denominator side you take the value of 27, and if you add, then you reach to a point which is 5.49 value. That is what is your critical value. So now this critical value is going to be important for you to decide whether null hypothesis is accepted or rejected. Okay, so now let's get into F distribution, where I have got a rejection range which is based on the critical value that you have, and just see where your calculated value is. You can just see that since this is 0, here it is 0, 1, 2, 2.40. It is somewhere here, right? So 2.40 is somewhere here, which is in the blue range, right? And where is the critical value? Critical value is 5.49, right? So now in this calculation, we found that our F score is lower as compared to a critical value. Once you have this, then in that case, basically you cannot reject the null hypothesis. That you cannot also say that null groups are different, right? But just imagine this F score is, let's say, more than 5.49. Then it is always somewhere here in the red zone, and if it is in the red region, then you can safely reject your null hypothesis. For example, let's say this value is, F ratio value is 10.40. Then in that case, safely you can say that this null hypothesis is rejected. That basically means groups are actually different. But in this case, we do not get that liberty to say that our score is less than the critical value. So F ratio 2.40, critical value 5.49. So the condition is critical value is greater than F. So null hypothesis is true in this case, and our conclusion is all groups are same in this in terms of variability, or in terms of the mark score, or in terms of whatever values they have. Conclusion, this was the problem at hand, where the teacher was not sure, or teacher was having a feeling that these groups are actually different, but the statistics of ANOVA told us that these groups are actually not different. They are the same groups. And that's it for today's ANOVA lecture. Okay, so thank you for your time, and keep learning, and see you in the next video. Bye bye.